Here we're talking about find the component of A along B. So when you see that notation, it's a different formula. That's different than the cosine of theta between the two vectors. That's the component of A along B is just A dot B over the magnitude of whatever that bottom vector is. Whatever that little one on the bottom is, that's the one that you put on the bottom here. So you only need one of the magnitudes. So there's my working answers for the first two. Here are my working answers for the second two. So you can pause those and get those down, just practice those. These are all pretty much the same type of problem. Let's practice one from scratch together, and we'll talk about one other problem, and then we'll be good there, okay? So if I want to find the component of A along B, when I see that notation, I'm going to have this formula memorized. And so the first thing I'm going to do is my dot product. So we'll go 5, 3. We're going to do the dot product with 6, negative 2. So I'm going to go 5 times 6, which is 30, plus 3 times negative 2, which is negative 6. And that's going to give me 24 right there, okay? Now, when you're doing this problem, if I'm doing the cosine of theta between the two vectors, I need to find the magnitude of A and the magnitude of B. But I'm doing the component formula, I only need to find the magnitude of the bottom vector. So I'm going to do the magnitude of B only. So I'm going to do the magnitude of B. Remember, the magnitude of the vector is the square root of that thing squared plus that thing squared. So that's going to be 6 squared plus negative 2 squared. That'll be 36 plus 4, which will give us the square root of 40. I'm going to break that down. That's 4 times 10, so I can reduce that to 2 radical 10. And when you do the component of A along B, all right, remember what you do. You're going to do the dot product, A dot B divided by the magnitude of that bottom vector, the magnitude of B. And so your dot product we found was 24. And then the magnitude of that B we found was the 2 radical 10. And this is just 24 divided by 2, which is going to be 12. And then the square root of 10 is on the bottom. And then if you have 12 over square root of 10, we can rationalize that. We can make that radical 10 over radical 10, which is going to turn into 12 radical 10. And a radical 10 times radical 10 is just going to give us a 10 on the bottom. But you could reduce this further. You can make that 12 over 10. You could reduce that to 6 over 5. So that's going to equal 6 radical 10 all over 5. And hopefully I got that right. Yeah, we got that answer right there. So there's the letter B we worked out. Letter A, you get a nice number. And then C and D, I just want you to practice those on your own. Pretty much the same type of deal as C and as letter B that we just got done working out. So again, if I just run through one real quickly here, do the dot product between the two vectors. Be careful with your arithmetic on there. And then do the magnitude of B. And then that's be your thing. And then when you do your component, you're going to just put the dot product on top and then that magnitude on the bottom. And then you can rationalize if you need to. You can reduce the fraction if you need to and be good with that.